Realize the full potential of Lightwave's powerful features. Discover essential techniques for the advanced modeling and animation capabilities of endomorphs, skelegons, weight maps, multi-meshes, and more. Create multi-layered and animated textures, gradients, and apply UV mapping. Add realism to your rendering environment with volumetrics, caustics, and radiosity techniques. Plus, a variety of modeling, animation, surfacing, and rendering tips and tricks. Cut your learning curve and increase your animation ability with this powerful training series. Discover the fundamental concepts of skelegons and weight maps for creating character models that bend and flex at your command. Brian Freisinger demonstrates the tips and techniques of applying deformation structures in Lightwave, the key to effective character model animation. Learn interface setup tips, skelegon characteristics, proper bone placement, editing tools, skeletal hierarchy, weight map assignment and application, the essential character animation setup techniques for maximum control and flexibility. Learn to create high-quality animated graphics with hardcore Lightwave logos. Digital artist Tony Stutterheim provides hands-on instruction for modeling, composition, and animation. Learn special effects, lighting tricks, and surface techniques. Build text objects, convert logo artwork, add dimension, motion sequences, and lighting effects to build network-style animation. Take an insightful look at these key concepts for creating graphic and logo animation in Lightwave 3D. Emmy Award-winning special effects artist Ron Thornton reveals his secrets for 3D modeling, animation, and special effects. This powerful video training series provides techniques for creating complex models with highly detailed surfaces, integrating them seamlessly with live footage, then applying explosive pyrotechnics. And with the Digital Effects Collection CD-ROM, you'll be able to follow along with the actual models and scene files created by Ron himself. Discover the power of Aura with a wide variety of 2D paint and animation techniques for logos, text, and image processing. Learn anim brush effects, stroke recorder techniques, rotoscoping, color keying, wipe effects, image mapping, and more. Apply Aura's powerful scripting capabilities for complex image manipulation. Create multi-layered composites, dynamic logo animation, and textured imagery, all with this powerful animation tool. Learn to master the technical aspects of multi-layered animation and special effects. Motion graphics experts Trish and Chris Meyer provide the techniques for combining film, video, 3D animation, and still imagery for flawless output. Learn about alpha channels, pull-down, fields and frame rates, pixel aspect ratios, and image quality gotchas. These system-independent concepts are shown using After Effects, Photoshop, Illustrator, Commotion, and Cinema 4D XL. All this and more, available now from Desktop Images. Dear video professional, the elements of this videotape represent the work of creative professionals like yourself. Unauthorized duplication of this tape not only is a federal crime, but also contributes to the destruction of an industry that you helped create. Please do your part by not duplicating this videotape. Thank you.
Hi, I'm Brad Peebler, and on this tape I'm going to be showing you some more advanced techniques for customizing your interface. We'll take a look at a lot of the behaviors of the modeling tools in Lightwave, as well as some of the more advanced technologies sort of under the hood and how you can use those to your advantage. Let's go ahead and get started. Okay, let's go ahead and take a look at more advanced configuration of the modeler interface. Now in the Get Started tape I showed you that I have a little setup that I like to use where I have my point statistics open. I like to keep my layers window open and my numeric floating palette as well. So once I've got those all up there, they'll stay. And the nice thing is once I've put those into a position, the next time I open them, they'll be there for me. So that's pretty good. All right, now what I want to show you is not so much about viewports and floating palettes, but more about how to configure our interface over here. You may want to change the way the buttons are laid out, or you may have a lot of plugins. As you can see here in our additional pop-up, these are all functions that have been either added to Modeler or were built into Modeler and haven't had buttons assigned to them. So there's a lot of different functions in here. A lot of these are utilities type tools that don't necessarily get used a lot, but other times there are tools that you'll actually use quite a bit. Okay, so first of all, what I'm going to do is I'm going to show you how we can take all these functions and we can push them onto their own tab instead of having them all in this big giant pop-up here. So what we want to do is go to your Preferences option up here in the top corner, and we can see that the first option is Edit Menu Layout. So if we open that up, we get our Configuring Menus editor. So what you'll see is over here on the right-hand side of the window, you've got the options for your bottom edge, which is down at the bottom of the screen, your main menu, which are the tabs across the top, your left mouse button, which is your contextual menu pop-up using Control-Shift and your left mouse, your middle mouse, again Control-Shift and middle mouse, and your right mouse menu options, which is right mouse with Control-Shift. If you're on the Macintosh, you need to use the Option key and the Apple key instead of the two mouse buttons. Although I do recommend on the Macintosh machines getting a 2 or 3 button mouse with drivers that allow you to set it up to work as the Option and Alt option. Okay, so we want to go ahead and go into our additional pop-up. So to do that, we notice under our main menu, there's an Objects pop-up, and inside that we have 2 other pop-ups. The first one's going to be our File pop-down, and you can see here there's a File group, the Preferences group, and there's our Additional. So you can see inside of here, there's all these functions that are in that pop-up. So what I want to do is create a new tab at the top level. So I'll select my Objects here, and I'll say New Group. That puts a new group. Now you notice it put it inside the Objects pop-up, and if you look at the corner of my window here, you'll see there's now a new group. That's because it's set in one level down under Objects. I want it to be at the same level of Objects, so it becomes a tab. Now you can see I've created a new tab called New Group, and there it is up on my screen, and you'll notice that on the side here, there are no tools assigned to it. So first thing I want to do is rename that. So we click on Rename, and we'll just call this Additional 1 for giggles. Okay, and you notice there it is, Additional 1 now, nicely renamed on my interface. Now the next thing I want to do is actually go in here and start adding some of those tools. So if I want to take Delete, let's move that from my pop-up into Additional. See, if I click on Additional now, you can see here it is right there. Now one thing I like to do is actually add a title bar at the top. So again, I'll say New Group, move that to the top level there, and you can see it's nicely labeled New Group. We can rename that to Brad's Tools, and you'll see now I've got that. Now one thing you can do also, you notice there's a little gap between here. If you want to make them a little tighter, drag your tool up onto the title bar, and that moves it up and make it a child instead of being at the same level. So now you notice the space is much closer, so it just sort of cleans things up a little bit. Now the other thing you can do in my additional pop-up, I'd like to get these out of the additional pop-up, but I don't necessarily need them to be buttons because I use, like, for example, my keyboard equivalent for my zooming. So I can just delete these. Now it's not like it's actually deleting them off hard drive or anything. It's just taking them out of the additional pop-up, not assigning them. So actually what you'll do is you'll find them over here unassigned once you've taken them out. Let's go ahead and move swap out. The weight maps and texture mapping, I do all that from the interface that's got the buttons down the bottom. Toggling view is a keyboard equivalent. I like weld average a lot, so I'm going to move that up in there. I like clear map. You get the idea. You can drag and drop these things around. Now I've got a configuration that I have created on disk here that we'll go ahead and load up so I can show you a little bit more advanced creating our own pop-ups and other ways to organize the interface. So to do that, you can simply save your configuration if you like, and then when you want to bring it back up, cleverly click on Load. And now I've got my new config settings loaded in. So we can see here is I've actually added 2 tabs, one additional 1 and one's called additional 2. And these just contain a lot of the tools that were in that additional pop-up. So we want to take a look at those. We can just pop those up. Again, you can select that by clicking on the listing. And you'll notice that under my VMAP tools over here, I've got about 5 different options for VMAP tools that I can choose from. But I can actually further categorize these or organize these by creating my own custom pop-up. So to do that, we're going to go into our VMAP tools here, and we'll go ahead and create a new group. And that's the new group here. And you notice when I drag it to the top level, it becomes a pop-up. Now there's nothing in that pop-up at the moment, so I need to drag these up and make them children of that same group. So if I just drag these up, just simple drag and drop, that puts those all inside of the new group pop-up. And of course we want to rename this, and we'll call it VMAP helpers. All right, there it is. Now I've got my VMAP helpers with a pop-up. So if I close that out, you can see there are my tools. Now this can be very useful since there are a lot of ways to add new functions to Lightwave, including third-party plugins, free plugins you can find on the internet, L scripts that you may create on your own. You can imagine that the list of tools that you'll have access to is going to become very large. So if you want to categorize those, you can create your own groups, your own tabs, and your own pop-ups to really organize those new functions as you go along. Okay, and of course one more thing to point out is that we want to save these configs once we've created them. So if we go back in here, we can just type save, or click on save, and we'll just call that VMAPs, and it's all good. Now, once I've got that saved, another thing I might want to do actually is be aware of the default button here. And the reason being is that sometimes if you're talking to someone about Lightwave, or you're on the phone and you're sharing tips with your friend, or perhaps you're talking to technical support, it's really important that your menu layout be the same as the one that they're talking about. And you just click on default, and that'll take you right back to the default shipping settings. And of course, when you want to get back to your settings, you can just load it from the load button. So important to know. Make sure when you call tech support, you do click on default so that they're talking about the same interface that you are. That'll help avoid confusion. Okay, now that our menus are configured the way we want it, I want to go ahead and show you a little bit more advanced techniques for editing your presets for viewports. In the Get Started tape, I showed you how you can change your viewport configuration, do multiple viewports, change the different display settings, but there's a nice way that you can create your own presets of those things, either of the entire interface or just of a single window pane. Let's take a look at how we would do that. First of all, we're in our standard quad view, which I like quite a bit, and I usually stay in that, but we're going to go ahead and change that a little bit. You'll notice that our viewport here, viewport number 2, already has a custom background. Normally this is going to be gray. I've set it to a nice blue, and there's also no grid plane on the in the viewport either. So that's some configuration that I had changed. So if I want to create a custom preset for that, I'll hold down on the keyboard my control key, and then I hit one of the numeric keypad entries. Doesn't matter. I'll go ahead and hit number 1. Now that brings up my Save View Preset options, as you can see here. And you can notice that first of all, I've got a type listing, and that can be the whole window or a single pane. Now since I was on my mouse pointer was over the second viewport when I hit that, if I say single pane, it'll save that for just that Windows settings. So I can come in here and we can just call that standard view, and I'll say no edit to remind me that I don't see my cages or my points in this view. I'm just seeing it in a sort of unadulterated 3D view. And then I can choose whether I want to save mapping type, rendering style, and independent settings. So the mapping type would be what type of image mapping I'm using. The rendering style would be what kind of OpenGL. And then independence is going to set what type of controls are independent for that viewport. Things like zoom, whether the cages are visible, that sort of thing. So we say OK. Now if I go into my display here options once again and go into my viewports, you'll see under viewport I've got a presets pop up, and now in there is my standard view no edit. So at any point if I want to change any of my windows to that setting, I can just go in here, pick the window number, and then choose that preset. I can create as many of these as I want to. Also, that preset is now attached to my numeric keyboard number 1, so I can address it that way as well. Now if I want to do one for the entire window, I can just come out here and once again I'll say control, and this time I'll go with number 2. That brings it up. And now I'll say whole window, and we'll call this one Brad's standard setup. Okay? And again, I can choose visibility, which is going to set what's visible on all the windows, my backdrop color, which I have set already, and my view sizes. If you drag the port handles around a little bit and you change your window size, you can actually save that in that config as well. So now I say OK. And once again, if I go to D, now under the layout standard window, not the viewports does the individual viewports. Layout shows all the viewports. You'll see that under presets here, I have Brad's standard setup, and I can choose that at any point as well now. So I've got my built-in presets, and then I can add my own presets down here. Okay, so the next thing I want to talk to you about is the content directory. And setting the content directory is something we've always done in Lightwave layout. We've never done it before in Modeler. The reason being, the content directory is a way to help us tell the application where to find certain files that relate to other files. And in Modeler, it was just working with the geometry file. Now we can actually have image maps on the model in the modeling application. So we need to tell Lightwave through the content directory structure where to find those images. Now here's the way the content directory structure works. When we're going to load a file, the file may be on a hard drive, and that hard drive may be D, or if you're on the Mac, it may be called My Hard Drive. Regardless, you've got your drive designation, followed by the name of the root directory, or what we call the content directory. And then inside of that, we might have 3D, then objects, and then our desired file, which is ball. So this is the entire path name, okay? So what we would define as the content directory path is the first part of that, D, getting started, 3D. So we would define that as our content directory in Lightwave and or Modeler. Then when we save that, if we do something like load an object in the scene file reference, instead of having this entire hard-coded path to that location on the drive, would only show load object, objects, ball.lwo. This way, if you move your scene file or your objects, it doesn't matter what drive you put it on, as long as you retarget your content directory, so the first half of that is no longer drive specific. This also helps in moving from one platform type to another because, as I mentioned, PC drive names are going to be much different than Mac drive names. Now again, in Modeler this is important because we can attach images to object files, and we need to make sure that inside the object file we never have a drive letter stored, because those drive letters will change or be broken as we move that content from machine to machine. In Lightwave, there are a lot of primitive tools for creating geometry and a lot of modifiers for manipulating that geometry. However, if we look just past the surface, you'll find that there are a lot of options for creating these primitives and using the modifiers that go well beyond the basic usage. Let's take a look at some of those. First of all, if we take a look at our primitives tools here, if I go ahead and click on box, you'll notice that the numeric state when it first opens up is ghosted. That means the tool is inactive. Now, one problem this creates is if you want to create a default box, you can see here, I've got the settings for a 1 meter box exactly. But if I click on the screen, the palette becomes active, but you see my values have changed to match the values that I'm setting on screen here. So if I want to go in there and get that exact 1 meter box again, I have to simply drag this out to match the 1 meter. And you can see it can be tedious. You know, I had those values right there. It's kind of maddening that I couldn't just pick them. So what I can do, if we've got the values set sort of something random like this, I can always go back here and hit reset. Another way to do this, if I come in here with my box tool and it's already set to gray, I can simply choose activate. And when I've activated it, it highlights the tool, turns it on with those values already set. Now the cool thing is if I change these values a little bit, let's just say I set to -1, -1, -1, okay? And then I shut that off. Now if I come back to reset it, or activate it again rather, it's stored that data, so I've still got those settings for the object. And again, if I want to go back to my default, I can just say reset, and that takes me to my default 1 meter cube. Also in the numeric panel are segment controls, so I can add segments to my object. So you can see as I'm dragging this out, let me just change this view here to wireframe shade so you can see a wireframe view. And we'll zoom in a little bit. You notice as I'm dragging these spinners, it's changing the number of segments on the object. So you can change the geometry in real time until you get it just the way you want it. And you'll notice if we go ahead and go to the tools like the ball tool, disc tool, cone, they all have the same basic setup. So if I'm working with an object, you can see, again, if I want to start with a default sphere, I just go over here to activate, and that brings it right in. The sphere itself, instead of having slices, has sides and segments, so you can adjust those things, again, real time, to change the resolution of your sphere and see exactly what it's going to look like while you're working with it. Disk, same basic principle. We activate that, sides and segments, your center position, top and bottom, so we can set the length of the cone, or the disk rather. And then the cone tool, again, if we just activate, you can see the cone allows you to choose an angle or an axis, so you can spin that around which direction it's going to be created, which way the point goes. And again, segments, so if you want to go ahead and add segments to the cone, and sides, so you can decrease the resolution or increase the resolution at will. And finally, you've got some options for sketch, where you can actually go in here and choose whether you're going to be sketching a curve. So if I sketch this out, it automatically creates a curve for me. Or I can set this to face. So after I've done sketch, if I'm finished sketching, it creates an actual polygon for me automatically. So those are the sketch options. Text is interesting. Text is allowing us now to do some nice things with kerning automatically. Size by grabbing the handle here. You can drag this around. An interesting thing to note, though, you'll see that there's only a couple of fonts loaded. So if I want to create new fonts or load new fonts, instead of doing it from the numeric palette of text, we go up to the Edit Fonts button over here and click on that, and that allows us to add true types or type 1 and make a list of fonts that get loaded upon the activation of Modeler. Once we've got those in here, let's say I want to bring in a true type font, and we'll just add Bookman Old Style. Now that's added to the list, so when I come back over here, I can pick that from my pop-up. If I start to type, let's go ahead and type in hello. You notice I can grab this widget here, and just like before, in Lightwave I can scale the size of the text, but now there's a little widget here that I can grab that's going to adjust the kerning automatically, which is kind of cool. You can drag that around in real time. Or you can use your spinners again to do this numerically, or if I want accurate number, I can just type that in. Now notice some of these buttons here got a little truncated. That's because the button labels were too long for this short button. I can grab the numeric palette and drag it out so that I can actually see the entire menu there. So again, you can change your axis, X, Y, Z. You can also change the justification, so now it's going to be center justified, or right justified, or left justified. Pretty straightforward stuff. Finally, you've got your pen tool, and the pen tool is basically just a way to create points that automatically creates the polygon that would connect those dots. And so if you want to adjust those things, you can go here and say let's adjust, and it's going to be adjusting the value of the last point that you created. If you've used Lightwave versions prior to 6, what you'll find is that in the new versions, a lot of the default behaviors for their multipliers have changed slightly. We're going to take a few minutes here to go over some of those tools and how they operate now, and just to give you a quick orientation. So let's take a look here. Go ahead and clear this out, and we'll go back to our little default primitives guys. And I can use my numeric pad 1 because I said a preset earlier. Isn't that clever how that works? I'm using my own tools there. And we'll go ahead and move this back over. Okay, so what I'm going to do is go ahead and use some of the modification tools. First of all, I'm going to show you the behavior of some of the new multiply tools. So to do that, I'm going to go ahead and load another object here. And we'll go ahead and bring in our little lemon half. And what you'll see is I've got just a simple subpatch object that's been cut in half. And this is a pretty standard thing to do when you're modeling with subpatch objects, when you're modeling a face or a character, is to work on one side of it. And then once we're done with working on half of it, we'll mirror that across. So I want to show you the mirror tool now and how it works in Lightwave 6. What you'll do is you'll go in, instead of defining from the top axis, you can define from any axis, click on it, and then as you drag this around, you can see I'm actually changing the axis of mirror. Now what you'll notice also is when I bring it around and I get close, as soon as these points line up, it snaps together. And you see how the spline curve actually tightens up? That's because it's doing an automatic merge points. As soon as it's mirrored, as soon as the points are at the same axis, it's actually merging them for me. You can see here that's an option on my numerics panel, is merge points. If I turn that off, notice the seam that I get here in the subpatch object. Because when the patches come together in an unmerged fashion, let's go ahead and look at this in a wireframe view here, you can see the curvature is solving up to this point as if it's the last point in the curve. That's happening on the other side as well, so there's no blending between them. So what we would typically do in prior versions is mirror and then merge the points, so we thought, hey, let's just simplify that for you. And that way also you get a real visual way to see when in fact your object has been set to the appropriate axis. Because if we get there, bink, you can see it happening for us automatically. Now you can also change the position of the mirror by dragging this blue line here back and forth. That actually changes where it's going to mirror across. Or you can change that using the numerics panel. So here we have it visually. I can just grab the line and move it around. Again, gives you nice visual feedback when it pops together. Or I can come over here to my numeric palette and adjust this with my spinners. If I want to move it on the x-axis, you see I move that along here until it gets right to 0. This also gives you a way just to numerically say right at the 0 axis, boom, and then I'm done. Again, if you want to change your axis here, you can change that so you can see if you can mirror on the Y or the Z, or I can mirror right across the X, which is exactly what I want. So that's the way the mirror function works. Now I want to show you a little bit about the knife tool. So we'll go ahead and turn off mirror. This is another important thing. Prior versions to 6.0, you had the make tool. So once you were done, you would hit make, and that would disable the tool. If I just click over here, what that's going to do is turn it off. All right. So what you want to do is turn off the tool by just disabling it by turning it off here. Using the blank area is a good way to undo it, essentially, because it hasn't really been made. But since the geometry is already there, instead of having to make the geometry, you just need to disable the tool. Okay, so for the knife tool, what you'll see is it's now interactive. So if I click and drag, you can see it's starting to actually build the cut as I go. This is also very nice because as we move along here, you can see that areas where I break the 4-point limit for subpatch objects, it shows me the holes are going to be created. So I can just move this along until I get it in the right place. Once I've got that lined up, I can move my cursor to the middle and grab the line, and now I can drag this up and down as a straight line. Now another thing I can do, if I want to create another cut, instead of having to reset it, I can use my right mouse key here and just click in a lower place, and you see it's now created another slice there. I can just keep slicing the object by just moving the cursor and using my right mouse key to add cuts. Then my left mouse key allows me to edit that by, again, just grabbing that and moving it around. So you see that's the way the knife tool works. A very nice interactive way to slice up an object, which is very important when you're working with subdivision patches. And the next thing I want to do is go show you the lathe tool. So to do that, we'll empty our layer here. And I'm just going to create a quick box object on the side. And I'm going to turn on subpatches. And now I'm going to go to my multiply tab and choose lathe. And now to lathe, what I want to do is go down here, and in the bottom quadrant, it doesn't matter which one you choose because you can adjust the axis, but I'm going to click and drag this out. Now you see it's, as I rotate this around, it changes my axis of lathe. So I can spin that around. Now I can actually lathe around a non-standard axis, which is pretty cool. You can move that around there. I can grab it from the center. That's going to scale it. If we look in our perspective view, I can grab it from the handle here in the middle, and now I can see scaling the size of the ring, reducing it, bring it around. Now another thing that I can adjust, if I look here, you see there's a little tick mark. You kind of see it. Let's just rotate this around a little bit. You can see a little bit better. This line here, if I click and grab on that, that changes the rotation of the lathe. Basically, the start and end angle can be adjusted interactively by just grabbing this and bringing it around. So you can actually spin it more than once around. And you'll notice that my numeric palette here shows that I've spun that now negative 569 degrees. The end angle is 324 degrees. So I've got several rotations. I can just bring these back by spinning it. So that's a pretty cool thing to do. Now you may wonder, why do I want to be able to spin this beyond that connection point? Well, now if I use an offset here, so you'll see as I offset this, I can sort of corkscrew that out. And let's zoom this out a little bit. Keep working with my offset. Oops. Let's just crank that way up there. There we go. Now I can grab the handle and spin that around and create a little corkscrew. So that's kind of fun. Again, you can then go in and change the axis. So if you want to sort of pinch that along, or if you want to grab it and change your scale interactively, you can do that. There are numeric controls for the number of sides. So if you start to spin this a lot and it starts to break apart, you can actually change the number of sides to add resolution. So as I bring this down, let's see if we reduce it. You'll notice now, because there's too few segments, it's starting to get hard edges. Luckily, with the subpatch mode, it's trying to smooth that out for us. But you see the resolution's not quite high enough to give us a nice smooth path through there. So I just crank my sides up again, and that rounds it out. So it gives you a real nice way to work very quickly. Hey, look, I've made a phone cord. Isn't that nice? But you can make all kinds of cool stuff. Again, you can change your axis. You can reset here. Basically all the same controls. You'll notice that the numeric palette maintains some consistency between all the different tools. So you'll feel comfortable. There may be some new options here and there, but for the most part, you'll be able to jump in and use these right away. So you can see the modifiers have become a lot more interactive and a lot more user-friendly. Things like bevel and smooth shift are also interactive now, and I'll be showing you how to use those when we do our little project-based work at the end. Next, what I want to show you is some of the numeric controls for the modifiers. Good old tools like move and rotate and shear have a whole new paradigm now that you can change the way they function with your numeric options. Let's take a look. So I'm going to go back to my little filler objects. Let me just load up the filler objects. There they are. And these little guys here, just some stand-ins that I can use to modify and move around. So what we're going to do is go over to our modify tools. And you'll notice that when I bring up my move tool, we get several options here. Of course, just your standard modification, but then there's also a fall off setting down here. What I'm going to do is I'm going to go ahead and grab this object here. I'm going to use my select connected tool. So we'll go ahead and just use the keyword equivalent. That selects all of them. This is a sub patch object. I'm going to go ahead and move it to a different layer. So I'm going to copy and paste that so we can just work just on this object. Now I've assigned some weights to this object. If we go into weight shaded view here and choose the weight, you'll see I've got some varying degrees of strength here. We covered weight maps in the Get Started tape. You'll remember with the manta ray project how we can use weight maps to change the way the object is deformed in layout. Well, we can also use those to change how it gets deformed in Modeler. But first, let's go ahead and take a look at the straight numeric options for move. So if we come over here, a typical move is just going to move it around, unadulterated. So as I click and drag at any viewport, right, straightforward stuff. Works like it always has. But now with fall off, I can choose different options. If I choose a linear fall off, you see I get a nice little window that shows a whole bunch of different controls. Let me go ahead and drag this out a little bit so we can see these little graphics here. What we need to do is define a fall off axis. So to do that, I'm going to click with my right mouse key in this window down here and drag up. And if you remember the Get Started tape, we showed using the linear fall off to create a weight map. What this shows us, this little widget here, is that at the base here, we've got a 0% amount of move. And at the top, we have a 100% amount of move. And all the way down this line, it's falling off in a linear fashion. So if I come up here and click and drag, you'll see that it's moving that with the fall off. All right? And you see that everything above this line moves the same amount. So that moves rigidly. And everything beneath it has that nice fall off to it. If you want the fall off to go all the way throughout the entire object, you just drag with your right mouse key all the way to the top, and now you get a completely linear fall off from top to bottom. Now there's more controls you have here. For example, you can change the axis automatically by switching back and forth. You can set it up so that it moves more in the middle here with that graphic widget, or so it moves more on top and bottom. So you get some interesting controls there. Now you can also change the curvature of these widgets. So you'll notice here I've got the bottom to top fall off. Then there's some presets. Linear is what we've been using. I can set an ease in, which eases in then falls up. I can set an ease out, so it takes slowly and then gets moving. And you see the widget here is actually representing those changes. So now it'll start off and the percentage of move will increase with that nice linear curve, or that nice spline curve rather. You've also got a smooth, which is sort of an ease in and ease out. And again, you can adjust these custom by just dragging these sliders here. So if you want to create your own version, you do that. And then once you've got that set, you'll notice that as I move it, it falls off with that amount of spline-based curvature affecting these points as I move it along. So that's the way the move tool works with those presets. You can also change these things numerically. This is basically the range. You can see that I've got a fixed range. If I set it to automatic, it's just going to use basically an automatic sizing for the object. So it's going to move from bottom to top, 0 to 100. Going to fixed is how I can define the custom setting exactly where the fall off is going to start and end. If I switch my tools, or my fall off rather, we've got some other options. There's radial. This is going to work in a radial array. So instead of the linear fall off, I can click and drag out a radial fall off. And if I only define it in one axis, it's going to be a consistent fall off in that radius all the way along this axis. If I want it to only affect a certain area, I can go to the other window and use my right mouse key again to drag out an area over here or reposition it. So now I've got a radial fall off that's only going to affect these points, leave these alone, and with the radial amount here. So if I click and drag, you can see it's causing a bulge there on the side of the object. Okay, so you can drag those around. That's how the radial works. It has the same presets that we had before. I can go linear, I can go ease in, ease out, smooth, just like the move tool did. So that should be getting familiar to you. You should recognize those. as you go from tool to tool. The next option is point. This is going to basically be like drag, where if you click on any point, it's got to fall off. Since this is a lot like drag, it's not something you're going to use all the time with move, but this is more useful when you're assigning weights and using some of the other tools, because remember, all of these fall-offs are available for any of the modify tools. Polygon is pretty cool. It allows you just to click on a single face and drag that out. So I can just click here and grab any one of those polygons and just drag it around. Kind of a cool way to work. Gives you a real interactive way to drag these things around without having to go in and select something, then move it. You just click and drag, and it goes. Kind of cool. This is especially useful when you're working with subdivision surfaces. As the spline curves smoothly interpolate between the points, you can use the polygon move option to drag those around, and you'll see a real nice smooth flowing result. Point radial is a lot like dragnet. Again, with move, it's not so interesting, but when you start using it to apply weight maps, you can basically assign a radial area, radius, that you can then move all the points that are within, say, half a millimeter, or excuse me, 470 millimeters within that point will move along with the point that I grab. And then weight mode is one of the more interesting ones. Again, we covered how to assign weight maps and use them in layout. You can also use these weight maps in modeler for your modifiers. So again, where normally if I move my object with the fall off set to none, it'll move it rigidly. If I set my fall off to weight map, it will apply the value of the weight map as a strength percentage to the move tool. So as I click and drag, all the points that have the hot weight map are moving along with my mouse pointer, and the ones that don't have any value that are green are going to move, actually none in this case because they're set to 0. If you have blue weight maps, which are negative values, the points will actually move against your mouse pointer. So as I move to the left, any blue point would move to the right. It's kind of an interesting way to work. Again, with subdivision surfaces, this is a real interesting and fun way to modify objects very quickly. So you can see by getting a little deeper into the numeric controls, there's really a lot of power that can be uncovered. Now, we've been just using the fall-off options on the move tool, but you can imagine the types of cool effects you can create by using, for example, a radial fall-off on the rotation tool, or a weight map fall-off using the scale tool. There's all kinds of cool things you can do with those numeric options. Now, there's another tool, symmetry, that's going to be used a lot in the modeler these days. And we want to make sure that I show you and point out a few little gotchas that you should watch out for in the way symmetry behaves. Let's go ahead and take a look here. So to do this, I'm going to go ahead and bring in another object here. And I've got our little rabbit nerd model. And we'll go ahead and set this back to smooth shaded view. Get our numeric palette smoothed over there. Okay, so here we have our little cool rabbit character. And I'm going to use my 0 key to zoom into that window. And we're going to zoom in a little bit here. And what you'll see is, if I go to my move tool and I set my fall off to polygon, I can go ahead and click now on polygon, and it's going to adjust just one at a time. If I set my symmetry tool on, this gives me a way to modify the face very quickly by just grabbing polygons and sort of painting in that area. Now what I want to show you here, is when I zoom back out, if we look at the ears here, and I want to grab and drag the ears around, I'm going to go ahead and select all of the ear, and what I want to do is just move this ear over to the right. Now with symmetry turned on, this allows me to move one ear to the right, and the opposite ear will be moved in the same direction on the other side. So if I go ahead and hit T here, and I start to move, you'll notice, what's happening? It doesn't seem like my entire ear is moving over. The middle part is sort of pulling in the opposite direction. Well, let's take a look at why that's happening. Keep in mind that symmetry is acting along the y-axis here in this view, okay? Well, if we look closely, what we can see is the ears points, in order to make the ears stretch out like this, we had to stretch the original cage points clear over here. So this ear, to get this little bend here, has points on this side of the axis. Turn off my symmetry so you can see that. So you see these points here affect this part of the ear. So if I drag it over, you see, okay, that's what's affecting those points, or that curve. So obviously, if I have symmetry turned on, and I'm trying to move this ear, since this point is on this side of the axis, when I move this way, it's trying to do the same thing in the opposite direction that way. So what I'd have to do is actually turn off symmetry, get these points over, do my symmetry mode, and then pull the points back out. There's another thing you need to watch out for. A lot of times when you're working with a character, you'll want to change the way he's facing. So one way to do that is to simply use, there's a hotkey E and R that I use a lot, where I'll take my pointer and I'll set it right here in the middle, and as I hit R, you see it rotates around that axis. If I hit E, it just goes the opposite way. It's a quick way to hit a 90-degree rotation. But if I have symmetry turned on, now what's going to happen is it's going to try and rotate both sides opposite each other, and boom, you see there, we've just munged our object. So you can imagine that if you're working along and all of a sudden you did that, you would have no idea why it just happened. Keep in mind, if you get some sort of weird behavior, check out your symmetry option. If it's on, that could be what's causing the foul up. Just keep in mind, anytime you have symmetry turned on, it's going to try and recreate every action from one side of the axis to the other side of the axis, and then you'll be aware of when these little things creep up, and you can just disable symmetry, and then everything's happy again. Lightwave's been around for a lot of years, about 10 or 11 years actually, and as a result, there's a lot of content that's already been created in older formats of the Lightwave object. Now with the newer format of the object file, there's lots of extra data that can be stored. So what I'm going to do now is show you some ways to take those old model files and update them to the new system. You maybe find these models on the internet. You may find some freeware websites that have models. You can go to companies that have existing Lightwave models, or you yourself may have created object files of an older format. So let's go ahead and take a look at what we can do with those. The first thing I want to talk about is layered object formats. So I'm going to load in an object here, and this is from the old Lightwave 5.6 CD. In fact, I think it predates 5.6 even. And it's a robot arm. Now, typically, you'd find this as several different objects. Okay? And the reason for that is that in Lightwave layout, when we animate, we want to be able to animate each one of these sections independently. So what we would have done before is modeled each one of these portions of the model as separate model files. So we've had on disk an object file for each independent element that we want to be able to animate separately. Well, in the new object format, what we can do is store that all in one layered object format that can be then loaded in and independently manipulated. Okay, let's take a look at that. Here you can see the model file that I loaded, and again, it consists of 5 different layers that all make up that one object file. So that file called bot.arm, if we load that into layout, just go here to bot.arm, you can see now it all loads in as one file. That's pretty cool. Now there's a small problem with this though. You'll notice that the pivot point for this object here is still at the base of the object. The reason being, in Modeler, we determine our pivot point at the 0, 0, 0 axis. So you can see at this object level here, this is going to be our pivot point. Why is that bad? Well, let's take a look. If I go to rotate this in the animation, it's going to rotate around that point instead of around this joint here, and that, in fact, is very bad. So typically what we would do is go in and actually move the pivot point up to here. But that's kind of a hassle to do in this environment. So what we've done is added a method to change the pivot inside of the model file itself. So if we go to Tools, you'll see the Pivot option, and we turn that on. You notice I get a nice little pivot indicator. And I can just change that and move that right up here. Let's just go ahead and zoom in here a little bit. And that's exactly where I want that to rotate around, right around this axis here and here. Then I can go back to the next layer. And the base, that's fine for the pivot point there. Go back to layer 3. And we want the pivot point to be right here on this object. Go back to layer 2. This object should pivot from right here. And finally layer 1. This object should pivot from right here. So now we save this out, and we'll call this bot.arm pivot. And let's go ahead and clear this object out and bring in the pivot version. And now what you'll notice is, if I go through the objects, each object has its pivot point in the position that I replaced it. So if I go to rotate this guy here now, say rotate, you notice it rotates appropriately around that axis. That's exactly what I wanted. Okay, so that's a cool way to update those layered object files. So what you want to do is take your old models that consist of several different object files, load those in, copy each model object file into a second layer or a third layer in one object file itself, and then save that out. Move your pivot points, of course, prior to saving. And then when you bring that one object in, you've automatically got all those layers split out for you and ready to animate. Okay, let's take a look at another thing in updating our model files, and that is converting morph gizmo objects to endomorph targets. Let's go ahead and clean house a little bit here, clear this out, so we can close all objects. And now I'm going to load up a little talking dog made by one Ace Miles. And here we can see our Little talking dog file there. He had several morph targets, and one of them was having his mouth wide open. So we'll go ahead and load in talk open. This was a morph gizmo file, morph target, but now you can see we've got both objects here, talking dog and talking dog open. You'll notice in my layers palette, I've actually got both of them here. I've got my talking dog, and I can switch between them again in the layers as well. So what I'm going to do is I'm going to go ahead and copy this with my copy button. So I just hit C for copy, or I can click on the button down here. And I would go up to talking dog, go to a background layer, and hit V for paste. Okay? So now I've got this layer here is my original, and now the background layer is the morph target for mouth open. So what I'll do here is I'm going to set this one to the foreground, mouth open to the background, and under additional number 1, you'll see under modifiers, I assigned a function called background to morph. Okay, now again, if I hadn't have configured my interface, this would have just shown up in the additional pop-up, but now it's showing up under this tab. So if I click on background to morph, it's going to read the background file, and it's going to create a new endomorph. So we'll call this mouth.openWide. Say OK. And now it has read the background layer and created a morph target called mouth.openWide for the foreground. This object, I've already converted a lot of the other targets that Ace had made. So if we go into our morph pop-up here, you'll see there's all the old targets that were created, including the one I just made called mouth.openWide. And there you can see it moves from its base position here to the new open wide position there. These are all the other ones that were created by Ace as separate model files. And by using the same technique, I was able to convert all those now into one base model file with all those morph deltas intact as endomorphs. So that's pretty cool stuff. It's a pretty simple process to take those old morph gizmo strings of files and compress it down into one single file containing endomorphs. Once you've got that set up, of course, you can take that into layout, apply the morph mixer to animate that, but we'll save that for a later tape. Now what I want to show you is a method for changing model files that have surface groups that were created for selections into a new technology we call parts. A lot of times what people would do with Lightwave is use selection sets by creating surface names. Well, now in the new Lightwave object format, we can assign arbitrary names to any polygons. So we can then go back and use that as a selection tool. So what I'm going to do is use a tool called surface to parts to convert some arbitrarily made surface groups into parts groups. Let's go ahead and take a look. This is another model file that was made by Ace. And you'll see when I load this in here, that it's actually got a lot of extra surface data. These odd areas on the model file, probably a lot of you are familiar with working with 5.6 data or earlier, and you would create these groups so that you could then go in and select by surface name and edit that object that way. So if we come down here, you can see in our statistics window, under our pop-up here, our surface pop-up, we've got all these extra surfaces, okay? So if I wanted to select something like, let's just go with lip upper. Let's go with lip lower. There's 16 polygons there. I can click on plus, and that selects it. So this was a cool way, by changing the surface name, to give us a way that I could then modify that. So if I wanted to move this out to create a new morph target, you could do that. All right, so I can close his mouth or open his mouth by just changing those polygons. Now the downside is you end up with all these extra surfaces, and you got these funky surface colors. Well, now what we can do is we can turn this into a part. And a part will just give it a name without actually creating a surface or changing the color. So to do that, again, we're going to go to Additional, and under my VMap helpers, I've got a surface to parts setting. So I'll say surface material is lower lip. So we go down here to lip lower, and we'll call the surface name skin. We'll call it lip skin. That way, regardless of whether I'm using the lower or upper lip, I can have one surface that encompasses all of it. So we'll say OK. And now you'll see down here underneath our surface pop-up, there's another pop-up which shows parts. And you can see I've got a part selected. Now if you just wanted to create your own parts without basing it on surfaces, let's say I want to create a part for the ear, I can come over here to the polygon and I can select these polygons here. And if I want that to be a selection set, I go to my polygon tool and I say part under transform, and it allows me to just name that directly. So we'll call that right ear. Okay, so that's how I manually make those parts, and you'll see again in my pop-up down here in the bottom right-hand corner of my polygon statistics. Now I've got the lip lower that I can select here, and I've got my ear, which I can deselect or select from that pop-up as well. And you'll notice also that when I did my surface to parts, I've got a new surface name, so this went to its default gray. I could then copy this skin tone onto that if I want as well. So it gives you a nice way to take those old 5.6 or earlier models with arbitrary surfaces and convert those into selection parts with polygon names. Next, I want to explain a little bit about VMAPs. VMAPs are very important for many different aspects in modeling. First of all, when we were adding weights to the model file, that was using a VMAP. We can deform the sub-patch curve by adding a weight also, and that's a VMAP as well. When we were working with the selection sets, that's also creating VMAPs. VMAP, by definition, is a vertex map, which basically means we're adding extra values to the point. Normally in a model file, each point just maintains its x, y, and z position in space. But with a VMAP, we can put extra data on that point as well. So, as I mentioned in the case of weights, we're adding a single value to the point, anywhere from 0 to 100%, as we are adjusting that weight to influence the modifiers. In the case of a UV texture, it's two values, u and v coordinates on the map space, so that we know we have the x, y, z space in the point, but also the corresponding texture value as well. In the case of a morph delta or an endomorph placement, we have three values, x, y, and z displacement. So we have our original x, y, and z point space location, and then we have the delta, which is the endomorph, which tells us now take that for this endomorph and move it another x, y, and z from that location. So all these things get stored together inside of different VMAP types, and right now I want to show you how we can create and edit UV maps as well as endomorph VMAPs. All right, let's take a look at that. All right, first of all, let's go ahead and clear out all these objects here. Just close all objects, get a nice fresh workspace. So let's go ahead and load up an object here that doesn't have any UV coordinates assigned to it yet. So here we have just a base character, and we can see nice looking model there, made by one Jason Linhart. We're going to go just to the first layer, which contains just the skin of the face. And what I want to do is create a UV map that I can do a couple things with. One, I can paint on that map in a paint program to generate my texture, and then I can use that UV map to assign the texture back to the model. So first of all, what we need to do is create a UV map for the object. To do that, we come down here and we'll find at the bottom of our interface three options, W, T, and M. W is for weight. This is where we create standard weight maps and subdivision surface weight maps. We did that earlier. M is for morph. This is where we create endomorph maps. And you can see this model already has several created. T is for texture. And this is where we create UV texture maps. Pretty clever. Say new. And we're going to call this head map. Say OK. And magically we have a map created. Now what we need to do is we need to define the map. So to define the map, we go to our Tools menu, and under Tools is an option called Make UVs. So we've got a map created. Now we need to assign the UVs to that map. So to do that, we come in here, we choose the texture name, which is head map, and we choose the appropriate mapping type. Now, the thing is, we need to start with a projection of some sort to get a base level of the UV coordinates, and then we can take and manipulate those. In this case, since the head is a pretty cylindrical item, we can say head map cylindrical mapping type on the y-axis, because we want the y-axis to be the mapping area of the cylinder. We'll say OK, and that has created a new UV map. To view that, we can change any of our viewports to a UV texture mode by choosing our pop-up here. We say UV texture, and now if we hit our A for auto fit, you can see that my head has been unwrapped in a cylindrical projection. Now to paint on this, there's a little technique you can use. Let's just say we want to zoom into this window, so I use my numeric keypad, the number 0 right here. We just hit that, bing, and that zooms out to fit this window into screen. Now I'm going to zoom in a little bit with my A key again, and what I can do now is I can do a print screen. So if I hit print screen, like this, now I can slide over to any program like Aura or Photoshop or whatever it is, And in Aura, I can just tell it the clipboard. I say new layer from clipboard, and now I've got it right in there. Now what you'll want to do if you're going to paint on this is, first of all, you want to make sure you're painting on another layer. So we'll put a layer on top of that one that I can paint on. That way I can turn off this layer because I don't want this to be part of the map. I just want to use it as reference. But another important thing is you actually want to crop out just the part of the UVs that fit inside this box here. Okay, so if we go with our crop tool, we can come in here and we would just then basically drag this out right along the edges of that black line. The reason we're doing that is that black line is defining for us what the 0 to 1 UV space is, and all the UV coordinates have to fit inside that. So we want our map, our image map that we've painted, to fit perfectly inside that square as well. Once we have our texture painted, we can bring that in. Let's just go back over here to Modeler. And we go to our image editor, and we can see that we've loaded in an image that was created based on that map. So if we double click on it, we can open that up. You can see here it is. Got a nice little area that sort of fits down along the back of the neck. Some area to darken the eyes, darken the eyebrows here, or the eye holes here, and then darken the lips as well. Let's go ahead and take a look at that as it relates to the UV texture here. Okay. So we go to our D key for display options, choose backdrop. This is viewport number 3. And we'll assign the UV head base in there. And you can see now how this spine was painted right along the back of the head. The dark spots correlate to the eyes. The dark mouth area correlates to the lips. So that's pretty good. What I want to do now is actually assign that as a surface. So to do that, we need to go into our surface editor. This is one of the nice things, being able to have the entire surface editor accessible right there in the modeling environment. We can just go ahead and open up our surface editor, and under color, for the skin, I need to choose the skin first. Color, texture. Layer type is image map. Projection type is UV. I need to choose the UV map, because you may have multiple. And I need to choose the image. Okay? Now if we set our viewport to texture view, it'll update the OpenGL textures. And you can see now I've got my UV textured head with the darker eyes. I've got, if we go to the back side of the object and roll this around, let me go ahead and see that there. You can see how the texture maps perfectly right along the object there. Let me go ahead and turn down my subdivision patch level. It's really high. It'll allow me to move a little more quickly. There we go. So you can see here as we zoom in a little bit, the darkening of the eyes, the darkening of the mouth, and of course, the texture on the back of the head. If you want to change this or edit it a little bit, you can actually do things like use my stretch. So if I want to just stretch this in a little bit, you can see as I update that, it's going to update the texture's position. You can stretch it back out. You notice now the darkening of the eyes go in there. I'm starting to slide the mouth off of its original spot. Or you can just grab individual points. If I want to grab the mouth, just grab like this, move all those down a little bit, and moving the points down is going to move the mouth map up along that area. So you can use any of your modify tools in Modeler on the UV axis as well. You can see I've moved the points of the back of the head. Just grab these, and we'll just slide them over a little bit. You see as I move it, that adjusts the position of the texture. If you want to scale a little bit to make that a larger area on the back of the head, you can stretch that across, or I can scale it up over like that. So you get the idea. Again, any of your modeler's tools, I can even rotate these points, and that's going to rotate that across. Some pretty wacky effects you can generate with the UV editing directly on the map. So in effect, you're able to distort the map by creating a distortion of the underlying UV coordinates. Because the UV texture view is integrated into one of the viewports, some people might assume that by changing those points, you're actually modifying the model. You're not. What you're modifying is the UV data that's stored on the points. Remember, there's now 2 sets of information stored at each vertex. There's XYZ data for the position of the point in space, and then there's UV information, which stores the 2 coordinates necessary to map each vertex to its corresponding pixel on the image map. So as I manipulate that unfolded view in the UV window, I'm not changing X, Y, and Z values, I'm only modifying UV values and therefore changing the corresponding mapping type on the final mapped object. Okay, let's go ahead now and take a look at endomorphs. Okay, let's go ahead and reset a few things here. First of all, I want to set my window port back to back view, and we're going to turn this back to just a smooth shaded so we can have a little bit better performance without having to deal with the maps on there. Okay, so to create endomorphs, very similar to creating texture maps. We'll change the texture UV assignment to endomorph map assignment. So now you can see our object here is set on base, and you'll notice that there are a bunch of pre-created morphs already in this model file. I'm going to show you a number of ways to manipulate the existing ones, create new ones, and or just rename these. I think they're named kind of silly, so we'll rename some of those as well. But first of all, to create an endomorph, all we need to do is come down here to New, and say OK, and it generates a little pop-up that says Create Morph Map. Now, all these maps are going to be relative, which means the new location of points is relative to the old point instead of an absolute pointer in space. It's, most likely, you're going to stick to the relative mode almost all the time. So we're going to create a little morph map for the eyes. So I'll start with calling it eyes.closed. Okay. And we'll say, alrighty. Now you'll notice down here under my morph pop-up, eyes.closed is selected. So to work with that, what I'm going to do is I'm going to close his eyes, cleverly enough. So to do that, I happen to know that this model file was created with some selection sets, another one of those VMAP helpers that I was talking about. So let me show you how to create a selection set first, and then we'll show you utilizing some of those selection sets. To create a selection set, earlier I showed you how to create a part. A part is a selection set basically for polygons. A selection set allows me to assign it just to the vertex points in space. So if I select those points, let's just say we want to create a selection set, so anytime I want to get back to that exact selection, I can get there very quickly. We'll go over to Tools, choose Selection Sets under the selection options, and we'll call this Head Top, and say OK. And now, if I deselect all those points, in our point statistics pop-up, at the very bottom, you'll see we have Head Top, and if I choose that, click on the little plus, it selects those points. If I deselect them by clicking on the little minus. Well, cleverly, there's a eyelid left that I can choose, and that selects those, and an eyelid right. I can push plus and select those as well. And now what I'm going to do is I'm going to change this view to the right-hand view. No particular reason, except for it feels more comfortable for me that way. I guess it's because I'm right-handed. And I'm going to rotate these points around this axis here to sort of make them appear to close. So if we just drag those along, and then I'll turn on my symmetry mode and rotate them a little bit like this, just to close the eyes. And you can see I went a little too far. He's gone too far. There we go. Now we've got his little blinking mode there. Okay. So now I've got a morph called eyes closed. Now you can notice if I go back to base, I can go to eyes closed. Now, if I want to create one that's just a blink, or a wink rather, instead of going in and creating a new map and redoing that same edit, so I'm going to go over here to my additional tab that I created. And normally I would find these functions under the additional pop-up in the default mode. But since I created this VMAP helpers group, I'll find it right in here. So what I'm going to do is I'm going to go to VMAP copy. All right? And this is going to show me all the VMAPs in the model file. You can see there's a bunch of them. They're prefaced by their type. Here we have selection sets are labeled with pick. Morphs are labeled with morph, cleverly. Texture UVs are labeled with TXUV, so on and so forth. So what I want to do is I want to go to the one I just created, which was morph eyes closed. So I go right here, morph eyes closed, and I'm going to copy it to a new name, and I'm going to call that eyes.wink. I say OK. Now I have two endomorphs, one that's called eyes.close and one that's called eyes.wink. Now you notice they're exactly the same. Okay. What I want to do here is I'm going to go to eyes.wink. I'm going to select the point, turn off symmetry first of all. select the points that make up eyelid right, again by using my selection set. Isn't that clever? Go back to my additional tab, which once again you'll find in your additional pop-up unless you created the same tab. And I'm going to say clear map from vertices. So this is going to look at those vertices that are selected and remove the map from them, which in essence opens his eye again. So now, if we look at it, eyes wink, I've got a winking effect. Eyes closed, I've got the closed effect. So keep in mind when you're working with VMaps, you don't have to recreate the effect on each VMap. You can use one VMap as a starting point for another one by using the VMap copy. Now you'll notice when I'm creating these VMaps, I always start with a name and then I put a dot and then followed by another identifier. The first part in the beginning, anything that comes before a dot in a endomorph name will become a tab on the endomorph mixer. The endomorph mixer is a little palette that comes up when you're animating, and it's a nice way to organize your endomorphs. So I typically group them, things like eyes, dot, and then the expressions, lips, dot, and the expression, or mouth, dot, and then the expression. So when I open the morph mixer, I'll have an eyes, lips, and mouth tabs with the appropriate sliders for each endomorph target underneath that. And we'll show you that visually here in a minute. One thing I want to show now is using that VMap copy, not only to copy VMaps, but also to rename them. It's pretty important when you're managing those VMaps to have some tools like this. So let's take a look. As I mentioned, I didn't really like these VMap names very much, especially things like m.lips and m.lower lip and chin. They don't do a lot for me. So I'm going to go and look at this one. This one's, to me, I think that's his mouth being closed, so I'm going to name it mouth closed. To do that, once again, in additional, I go back to my VMap copy, and we're going to choose morph called lips.closed, we can see right there, and I'm going to rename it to mouth.closed. I'm going to say, now, instead of just copying it, I need to tell it to clear the old VMap. So that's going to copy it to the new name and clear this one simultaneously, which is essentially doing the same thing as a rename. So say OK. Now if we go back here, you'll see my new target called mouth.closed. There it is. And now that other lips one is gone from the list. OK, and I can go through that, do the same thing. Here's M saying ooh. So we go back to VMap copy. We'll call this one mouth.ooh. I'll make it a little longer and say clear old map. There we go. And again, we come down here. There's my new ooh. And looking at the pop-up, you'll see the other ooh is gone. Now, something that's important to keep in mind, when you're working with layered objects, these background layers here, the eyes probably aren't going to be affected, but the mouth layer was kept separate. And this has the same exact targets as the other one. So you want to make sure that when you're adjusting those morph targets or those endomorph values, that you have all your layers that are pertinent selected, because as you're changing one, you're changing the others as well. Okay, once we have these things all renamed, we can take this then into layout for animation. And let me just go ahead and show you what our palette's going to look like as we add the endomorph mixer. Go ahead and clear the scene here. And let me just save this guy. So we'll save him as character head Brad. Pop back over. Bring him in. And we'll choose the first layer, which is the head layer. Go into the properties here. And under deformations, add displacement handler, morph mixer. You see it shows 9 morphs in 4 groups. Open it up. And here's that floating palette I was talking about. And you can see there's the eyes that I had earlier with closed, left blink, right blink, and wink. There's full face. There's the M one that I hadn't renamed yet. And then the mouth ones that I did rename. And you'll notice as I drag the slider, if I drag through to ooh, it updates on the screen here. Now one way you'll notice as I drag this, it's a little slow. That's because you can see my object here is very high definition. So one thing you want to keep in mind is adjusting your subpatch level so that you get something more interactive. Now you can see as I move this around, I get a nice interactive response on the model file itself. Let me just zoom in a little bit here. There we go. So you can see if I close his mouth, we'll go to ooh. If I want to go full face sneer, you see how that works. And again, it looks a little rough here, but keep in mind the end result is going to be much more smooth, and we can change and see that by updating our subpatch display level to match more closely the subpatch render level. So again, you can have something like a 10. You can see now it's very smooth. Or down to a 2, which gives us a nice compromise between speed and nice looking. Now, another thing to keep in mind here, the subdivision order that you find right here, this is pretty important. Subdivision order, when you're working with sub-patch objects, the object has to be taken from its cage form and smoothed down into that final polygonal object that's eventually going to be rendered. So if it gets subdivided first, what happens is the geometry engine called G-Core inside of Lightwave takes that original cage and will smooth it down the appropriate level, and then all deformations happen to that cage, or not to the cage, but to the subdivided object. If you set this to last, it'll do the deformation on the original cage, the low resolution cage, and then what gets subdivided will be the interpolation underneath that. It can actually oftentimes help to soften an effect. Here, I'll show you an example right now. If we change this, you can see this is on first. It's actually deforming this after it's been subdivided. So we have a high definition cage that's getting subdivided, so it doesn't have as much area to interpolate through. If I set this to last, you'll see that it actually smooths out, because now it's deforming the cage, and I can see that cage. Let me just turn that on here. If I go to my display, I've got an option for showing subpatch cages. And there you can see it. And now, what you see is, because it's subdividing after it's displaced the points, it's displacing this low-res cage here, and then subdividing to make it a smooth interpolation in between. And we can see that if we zoom in here a little bit. The nice smooth interpolation. If we have this set to first, the cage model gets frozen down into a polygon mesh, and then the displacement handler happens, and you can see that causes the points to be displaced in a more rigid fashion. Again, last or first. Now, depending on what you're doing, you may want to have it subdivided first. That may seem a little weird at first, but think about this. What if you're working with something like a flat plane that's going to turn into rippled water? If you displace the pre-subdivided cage, you may only be displacing 4 points, so it's not going to ripple very well. So you set the subdivision to first, and that subdivides or tessellates that plane into hundreds or thousands of polygons, and then the ripple displacement gets put onto that, giving you a nice flowing, smooth displacement across. So in that case, you want to go with subdivide first. In the case of a character like this, you want to deform the low-res cage first, and then have the displacement or the subdivision happen last. So in that case, you would set subdivision order to last. Okay, let's go ahead and take a look at one more thing relating to endomorphs. And this is pretty important. Very cool thing about endomorph creation and manipulation is that Modeler can interpolate when you add new geometry. What this means is, typically when working with a model file or a morphing sequence, you have to make sure that your morph targets have the exact same number of points and polygons as your original target object or your base object. Well, with endomorphs, because the targets are built into the file, we can make changes to the base object and not have to worry about that causing problems throughout, because it's going to interpolate those values. So for example, I'm going to go ahead and go to my point selection mode, and now my point statistics gives me my options for all my selection sets. So let's just go with upper lip drag. We'll select those, and I can zoom in a little bit and just roll that out a little bit. Okay, and I'll just scale these a little, okay, to make them have a little fatter lip. And maybe pull them up a little bit like that. So I've changed the base model file a little bit. Okay, keep working a little bit more. There we go. What you'll see is it's interpolated those changes throughout all of my other morph targets. So if I got lips closed, mouse saying ooh, it's translated those all the way across. So I can make simple changes like that. More importantly, I can add new geometry to the model file. So if I just go up here to the base again, and I take a couple polygons on the top of the head, we'll go to symmetry mode here. So I can select those, and we'll just bevel those real quick. Give some little horns. You can see now that I've done that, I still have my eyes closed, I still have the blinking, the winking, full face sneer. That's all happened appropriately. Because it's taking that and it's basically not saving separate object files, it's just maintaining the deltas for the morph data. And in fact, because it interpolates smart, if I subdivide the entire model file, what it's doing basically is it's looking at each point and finding its delta value for each target and creating an intermediate delta value for the point that's created in between. So we go down here again and we say, go to mouth oop. You'll see that it's still got the appropriate targets built in, and the new points that were created got the average values from the points around them. Okay, let's go ahead and take some of these tools we've learned and apply them into a little project and learn a few new tools on the way. Let's go ahead and get started here. First of all, let's go ahead and start off. We're going to make a hand, in fact. So to start with that, we're going to go ahead and create a quick box object. As you can see here, let's see, we want that to be the back view. And then from the side, we'll stretch it out a little bit. Okay, that's a good starting point. It's a little short, so just move that out. Great. Now what I want to do is create some segments. What I'll do generally when I'm building something like a hand is I'm going to spend a lot of time actually looking at my finger. Okay, so it's kind of a silly thing, but I look at my finger and I notice there's basically two seam areas from the tip. You've got a joint here and a joint there. I guess three if you consider the back joint as well. So I'm going to start thinking about adding geometry in these important areas where I need to have hinges on the model. So to do that, we're going to go ahead and go to our knife tool. That's under Multiply, Knife. And we're going to start slicing the object. Before I slice it, I'm going to go hit Tab, which turns it into a subdivisions patch object. See, there's our little beginnings of a finger. And now I'm going to slice, and then I'm going to use my right mouse key to slice a couple more times. And then back here a few more times. And let's give one more there, just for good measure. Okay. So now I've got my object file and I'm ready to start manipulating it. So we'll go in here and select the top, or the front rather, and I'm going to use my stretch tool to stretch this out a little bit. And you can see there, you start to get what looks like the side of the finger with the finger pad. Stretch it in a little bit. One thing I want to do is add a slice right down the middle so I can kind of round it out. You see it's a little squarish right now. So to do that, once again, we go to Knife. First of all, I'm going to center the model. So we can do that with our keyboard equivalent of F2. On the screen, it's under Modify Center, but use F2 and get used to that. It's easy to do. Okay. Multiply, Knife. And I'll just drag this up right along the 0 axis. I always want to check to make sure that my numeric value is set at 0 to make sure it's staying right along that axis. So if I ever need to use symmetry, I'll be okay because everything's equally located on either side of the object. In fact, in this case right now, I'm going to select the side points, but I'm going to turn on symmetry first so that when I select one side, it selects the other side. Then I can move that. Let's just zoom in a little bit here. And it'll move both sides at the same time, so sort of rounding out the shape of the object. Drag these up a little bit. There we go. Okay, so I've got the beginnings of my finger object. Now the next thing I need to do is start working on the joint or seam right behind the first knuckle, or right above the first knuckle. So we're going to take all these points here that I've created for that seam. Let's push them back a little bit so make sure we've got a nice finger pad there. And then I'm going to stretch these in a little ways, like this. And here's an important note. Notice I was stretching on all axes. I'm going to undo that, hold down Control, and when I hold down Control, that locks it to one axis. So I can drag that along until I get it pretty close. That's great. And now I'm just going to use my drag tool. Go to Modify, Drag, and let's zoom in here. G will center that, or go to center. So if I just put my pointer right there and hit G, it goes to center. That way I can zoom in quickly. And now I'm going to just start pushing these points up like this. And you see that kind of creates that little seam on the finger there. Now another thing I want to do is make it a little tighter. So I'm going to select these points and use Stretch, which again is my H tool. Stretch that along. So I start to get that nice looking seam on the underside of the finger, behind the finger pad. Then for the top of that, do the same basic techniques. Just going to grab all these points here. And first of all, I'm going to go ahead and stretch them back in. Then I'm going to take the middle ones and move those down just like I did before. I'm going to offset it just a little bit, so it's not quite perfectly symmetrical with the ones below. Pull this over. And there we start to get the top of that finger joint. Now what I also want to do is have this kind of bump up a little bit because my finger has a little bump ridge right there. So to do that, select all the points, pushed up just a little bit, Then deselect these, push up a little more, and maybe scale it out a little bit. Just general contouring. Now another thing I want to do is while I'm working on this, I'm going to create some selection sets because these will be important for later on while I'm working with the model. So I'm going to go ahead and select the finger here, fingertip. Now I'm going to use my expand selected, which on the keyboard is shift bracket. So if I expand that, it selects the next set of points, the next set of points. I can keep going until I get all the points I want. Let me just go ahead and zoom into this window. Hit Shift A, which will auto fit all those points. And you can see I've basically now selected all the points that lead up to that first joint. So now if I go under my tools, I can say selection sets, and we'll call this finger tip selection. I'll say OK. Now at any point I want to get back to that fingertip selection, I can just use my selection set options to pull that up. Now another thing I'm going to do while I'm at it is I'm going to assign a weight map to those points, so I won't have to think about it later. So what I'm going to do is I'm going to go to weights here. I'm going to say new weight, and now it's going to come up with an initial value of 100%. That's fine. I'm going to leave that on there. And the reason I'm creating this weight is I may want to use these later on for bones. This is one of the cool things about weight maps. So far, if you saw the Get Started tape, you saw me using the weight map value to change the way the inertia plugin was deforming the points to make it more rigid in certain areas. We've also used weight maps on this tape to modify the object in Modeler. Well, you can also create weight maps that you then assign to bones. So specific bones will only affect the points that have the weight map assigned to them. So in this case, I've created a selection set on the points and then added a weight for that. So when I have a bone in there, I can tell the bone to only read that weight map. So when I go to deform it, it'll only be calculating those points, and it won't have any crossover between the other fingers. Okay, the next thing I want to do is go ahead and select or create the middle knuckle portion. So again, we're going to go here to the middle section, and we'll just go ahead and stretch these in a little bit. And we'll take the middle two segments here, like this, and we'll just push them up a little, like that. And let's go ahead and create our quad view again so we can see that. Okay, and we're going to go ahead and stretch out that whole area so we've got a nice kind of bump. Okay, now I need to get an extra slice in here so that I can add the dimple right in the middle. So what I'm going to do is I'm going to employ a new tool called bandsaw. I'm going to go ahead and select one polygon. Since I have symmetry turned on, both of them get selected. So I'll deactivate symmetry and turn off one of the polygons. Now what I want to do is I want to select all the polygons in that strip. Now it would be easy enough for me just to go here and select those. But sometimes you'll have points crossing over an area so it's hard to get at. So what we can do is we can choose a tool called bandsaw. So if I go over here to my additional, again this would normally be in the additional pop-up, but I've now got it assigned to a button here. So I can say bandsaw, and I can tell it to select based on even, odd, or auto. If I set it to odd, or even rather, it's going to select a strip that goes all the way around here. And you can see that's one continuous strip. Now the reason this is important is if I was going to slice this object, I have to make sure that we slice along an area that doesn't break up our quadrilateral polygon support and cause a hole in the patch. If I undo that, go back to this selection, I can actually tell bandsaw to not only select those even ones, but enable a divide. So now based on this little gradient here, it's going to put a slice right in the middle of those polygons. So if I say OK, you can see that it not only selected the polygons in that strip, it also created a slice right in the middle. Now I wanted to go the other way, so I'll say undo, bandsaw, odd selection, and we'll leave the cut right in the middle. We'll say OK, and you can see now I've got effectively another series of points that I can manipulate to create that little dimple. So again, we go to our points mode here, and if we zoom in a little bit, you can see that I can take this and pull it down and in, pull it forward a little bit. I can grab these points, pull them forward, and that gives me more of a little crease there, like at the top of a knuckle. All right, and then again, I'm going to go ahead and just pull all these points up a little bit, deselect these, pull all these up a little bit, create more of a little ridge there, and we can change the contour by just dragging these out. You get the idea. You're just kind of pushing and pulling points until you get, the shape that you want. And you can see there, we're starting to get the finger. Now, I'm going to go ahead and create the same effect on the bottom here. So go to G, push these up, Take these points, stretch them together. Stretch them a little more. Okay. And just pull these up just a little bit more. There we go. Now I want to create the fingernail. And to do the fingernail, we need to go back to the front of the finger and select the polygons on top right here. Okay, so now what I'm going to do is I'm going to go ahead and first modify the fingertip a little bit more before we do that, so I get more of a tip at the front. So we zoom out a little bit, and I'm just going to select some points here on the front. Pull those straight out. There we go. And that gives us a little more of a fingertip. From there, we'll go ahead and use our poly selection mode to pick these two polys here so we can add the fingernail. So to do the fingernail, we're going to use smooth shift. So we'll go ahead here, and because the modifier, or multipliers rather, come up in an inactive state, if I right mouse on the screen, that'll activate it with the appropriate settings. Now if you want a different setting for your max smoothing angle, a lot of times people use smooth shift with a different setting there. You can change this value, undo it, and now when you activate it, it'll activate with that value. I want to have it on its reset value there, and we'll just go ahead and right click. Now you can see the smooth shift has added some new geometry for us, but it also caused a little bit of deformation. So what I'll do is I'll use my stretch tool to come back over here and stretch these polygons back in so it starts to become more like the finger again. And then I'm going to go ahead and do another subdivide with smooth shift, like this. And now we start to see the nail bed plate. So I'm going to go ahead and stretch these in a little bit more just to even this out a little bit. So stretch it here, and we'll flatten it down a little bit there. And let's just push it up a little bit to make it a little more flat. And then the next thing to do is to go ahead and select another layer here. And again, using smooth shift, right click, I can right click again. And that gives me two layers there that I can now pull that out. And you can see it's sort of extracting out the fingernail from that little area. Okay. Now another thing I want to do is actually bring the skin off the back here up a little bit along the edge. So what I can do for that is I can just rotate this along a little bit and then push these back and down in, which gives you the little fold over there that simulates the cuticle coming up over the fingertip or fingernail. Now the next thing I want to do is actually, I'm going to bring this down just a little bit, flatten it out a little bit there. That's pretty good. And then we'll rotate it. Okay. I could tweak on this for a while, but that's certainly fine. Now the next thing I need is a fingernail surface so we can make that look different than the rest of the finger. So to do that, I can go to my polygon surface transform, which is also the Q on the keyboard. So if I just hit the Q key here, that brings up my change surface name. And I'm going to type in here fingernail. Now there's a button here for make default. This, if I leave this on, any new polygons that get created will automatically be named fingernail. I don't want that. So I'm going to turn that off, say OK. And now I've got a surface named fingernail. So if I go to my surface editor, which is under the objects label, I can go ahead and choose fingernail. And let's go ahead and make that kind of specular. And we'll dim it down a little bit, kind of towards yellowish. And of course I can grab the default, which is the skin. And we'll pick a nice sort of skin tone there. And there we have. And I think now that the skin is a little darker, we can brighten up the fingernail a little bit. Or I could just pick a color. How's that? Okay, great. Now we've got our finger with fingernail in place, and most of the little seams in here as well. One more thing I'm going to do is go ahead and go over and add another slice along the back just to round that out a little bit. So we'll go ahead and grab these back points here, pull them out a little to lengthen the finger, and then use knife to slice that right along the back. Now the next thing I want to do, since I have my base geometry finished, is go ahead and add the weight map for the middle section of the finger and the base of the finger, as well as draw in some skelegons, so that when I copy and paste this to create the other fingers, those weight maps and skelegons get automatically translated into the new digits. All right, let's take a look at how we do this. First of all, we're going to go into our weight shaded view. And again, we can see we have our original weight which I set on the fingertip there. Next thing I'm going to do is go ahead and create a new weight for the base, but I'm going to go ahead and select those points first. So what I'm going to do to do that is select the base here and then expand my selection until I get to where I want it to end. Let me zoom in a little bit here, and I want it to go one more section so that I get all those points from the middle of the knuckle all the way back. And we'll call that finger base weight. And again, 100%. Great. So now I've got the base of the finger there. And now I need to do the midsection. So to do the midsection, again, I'm going to zoom in here. I'm going to go and deselect these and zoom in on those points. I want to make sure I don't get any crossover. So I'm making note of which points here are on the last weight. And now I'll just select these on this side. Then zoom out a little bit. And now I can carelessly select all these points here, knowing that I crossed over into the fingertip. Because I can come over here to my fingertip selection and tell it to subtract anybody that had fingertip selection. Now I know I only have points that were in the midsection because I've deselected any that were also assigned to the tip. And we say new, and this is going to be finger mid weight. Okay, so now I have my 3 weight maps, and those will get translated throughout the model as I copy and paste the fingers. All right, the next thing I need to do is add the skelegons. So to do that, let's just go back to our smooth shaded view here. And we're going to go to our additional. Again, this is something that normally you'll find in the pop-up under additional, but I've reorganized them so I can get to them more quickly. And there's one called Draw Skelegons. And it's a new plug-in tool class. I can just click and drag until I get to the midsection there. And then I can go to another view and click again to create the next finger. And then click again to create the next finger. And if I want to change the contouring a little bit, I can grab them on the bases at each one. And grab here, drag that up a little, drag that down, and drag that up like that. So that is my single finger. Now you can see that it's a little bit too straight here. And I really, if I look at my finger, I can see I've got sort of a ridge that kind of swells out around the knuckle. I did a good job of adding it from this view. When I look to the top, I need to go ahead and add those little deformations there as well. So to do that, pretty simple. I'm going to use the pole tool. I grab these points here. I'm going to modify pole 2 to find this area here, and then just kind of stretch these out like this. That kind of swells a little bit. And then we'll go ahead and actually select just the end points here. Pull those in slightly. Back. So that starts to give us the look we want, deformed there. And then we want to do the same thing up towards the front. So again, this time I'm just going to use a stretch, straight out stretch. Stretch this out a little bit, like that. Okay, just enough subtle difference so that there's some sort of bulging around the knuckles. And probably the same thing around the back. And again, to do that, we need to add an extra stitch. So we just go to knife here. We knife that through. And grab these points and just swell them out a little bit. Okay, good. So that's going to be the beginnings of the last knuckle joint there. Okay, now the next thing we need to do is copy this to make multiple versions of the finger. And to do that, I'm just going to go down to my copy on the bottom of the interface here. If I go copy, now it's been copied into a buffer. And when I go over to my multiply tab, what you can see is that there's actually a paste tool that's active now. And if I come in here, I can just click and paste the finger down. If you use your right mouse key, you can reposition. What I want to do is use my left mouse key, and that'll create another copy. And my left mouse key again. Let's do my right mouse key to get this separated a little. And then the left mouse key again to create another one. Now the next thing I need to do is actually, you can see that fingers are very rarely just straight up and down like this, and it also makes it difficult because your points are going to start to cross over. So we'll create the fingers in a nice relaxed position this way. And to do that, we need to select each finger and rotate it slightly to offset it from the others. So to do that, we'll simply start with the outside finger, and I'm going to use my select connected. If we go to display, tools, under selection, there's a select connection, which just rolls right along there. And I can rotate this out like this. And we'll move it over to get a little closer at the base. And that may be rotated a little too much. Now what I'm going to do is I'm going to leave that one selected, select some points on that one, and do select connected. Now I can rotate both of them, like that. Move it into place with the other one. And continue the process. Roll that along. Move that down and over. And now I've got all 4 fingers in a decent position. I'm going to go ahead and just rotate the whole thing around. And the reason I do this is so when I'm using my hand as reference, I've actually got my hand, I can put it up this way and I can kind of see exactly what it's going to look like versus that hand on screen. Okay, so there's the hand on screen there. We can see all 4 fingers. Now, one thing that looks a little odd is all the fingers are different sizes, or should be different sizes. In this case, they're all exactly the same. So what I'm going to do before I change the scale is I'm going to stitch these guys together. And to stitch them together, I'm going to use the weld tool to come in and weld these joints down here. So first of all, to simplify it, I'm going to turn off subdivision patches by hitting the Tab key on the keyboard. So I just, bam, hit that. And now I can zoom in here, and I can see very specifically where I'm working. Okay. So the other thing I can do, since I know I'm going to be just stitching these things, is I'm going to select these polygons here, these polygons, and these polygons. So just the ones I really need to be concerned with. And then I'm going to do a display, hide unselected. And that hides everything except for those polygons. So now I can get right in there and go to work. Okay, so let's just zoom in a little bit here. And to make it a little easier, I'm going to go to my surface menu. And on default, I'm going to set that to double-sided. So now I can see both sides, so I can see where the points are. All right, so let's just zoom in right here using my G key. I'll zoom in. And now I just go about welding these things. So what I do is I go points, select this point and this point. And under my tools, I have a weld command that'll weld those together. It tells me 2 points are welded. See, that just moves it right over there. So then I can select this point and this point. Again, Control W is the keyboard shortcut. That welds those together. We can use the G key to zoom up here real quick. And again, now we'll deselect the point, point, weld, point, point, weld. And then I know that once these are welded, I don't need these polygons here. So we can deselect those, or select those rather, and just kill them. All right. And then there's one here. Kill that. Because I don't need that. That was an internal polygon that's no longer going to be necessary. And I continue to work on that until I have this whole thing stitched together. And then it'll end up looking like this. So you can see all these stitched together. We have one seamless, continuous mesh. And if we unhide the entire hand, you can see they're nicely stitched together. So if we hit the Tab key again, it turns it back into our subdivision mode, and you can see now I've got a nice blended group of fingers there. And if I want to go ahead and pull out the back a little bit, I can just grab these guys here like this. Use my expand selected to make sure I've got just that ring of polygons. And then we'll just pull those straight back. That starts to give us the beginnings of the next section. All right, let's go ahead and stretch it up a little bit. Okay, now the next thing we need to do is change the size and scale of each finger so that as I look at my hand, I can see that, you know, the pinky is going to be the smallest. They don't change so much in diameter. Mostly they change in length. But we can change both of those things pretty easily. Let's take a look at how we do that. We go over here, and I'm going to go ahead and create the pinky first. And since I'm using my hand as reference, this is going to be the pinky. So I started by just doing a select connected, expand selection. Now, what you'll notice is, because I'm on an off axis here, if I go to stretch this, watch out as I try and stretch it down. See how it deforms in a strange way? I try and stretch it around, get this really weird deformation. So what I'm going to do is I'm going to go to my perspective view, and I'm going to rotate it around so that, in fact, let's zoom into this entirely. And like this. I'm going to rotate this view around a little bit until that looks like it's pretty much straight up and down. Oops. There we go, using my Alt key. And then, when I stretch on that axis now, I can stretch that right along, and it stretches pretty well. I can also then rotate from here if I want to. So it allows you to change your axis. If I want to look right down the center of it, like this, now I can use stretch to change the diameter just a little bit. And that's pretty good for the pinky. Let's go ahead and roll that over a little bit, like that. Okay, now looking at my hand, I see the next finger needs to be reduced as well. So we just grab this here, like that. And once again, we'll roll this over just a little bit and stretch it down. Maybe right about there. That's about right. And next finger. Again, using my select connected expansion. And here's an interesting thing about the view widget I should point out. If I use my left mouse key and I rotate, see it rotates on these axes this way. If I use my right mouse key, because you'll notice sometimes it gets a little off, if I use my right mouse key, it adjusts the other angle. So that gives me a real good way to adjust that quickly. Then I can pan this over, make sure that's right there. Since this is the largest finger, I don't need to edit it anyway, so we'll just skip that. And move over here to our index finger. And once again, using my right mouse key, just roll that right over, center it up, and stretch it down and in just a little bit. And this one should be slightly larger than the pinky. There we go. Okay, so there's the beginnings of the hand. The next thing we need is the thumb. And to get the thumb, I'm going to do an extra thing here. I'm going to create one more selection this way. And now I'm going to copy that. And let's go back to our quad view and zoom out here a little bit. And now using the paste tool again, I'll paste this down here. So this is going to become the thumb. And I copy that extra chunk there because you can see by copying that, essentially not only did I get the finger, but by copying that little extra bit here, I've got the beginnings for the joint that sort of pulls across from the thumb over to the hand. So kind of cool. Now we're going to go down here and grab all these polygons. And we need to position it to rotate it appropriately. So first of all, we'll rotate here. And then we'll move this over and up. And again, we can use the perspective view to kind of gauge how that's fitting in. Move it up there. And before I stitch it, let's go ahead and look here from the side. See, it needs to go up a little more. Before I stitch it like I did the fingers, I'm going to go ahead and adjust the thumb as well. So I'm going to go ahead and stretch that out. Go ahead and zoom here. Roll that around a little bit. And in this case, the thumb needs to be pretty short. Okay. And kind of squat. So we'll go ahead and roll this around a little bit. And the squat we get by rotating this view. And then scaling this out. That way I can stretch right along that axis, which makes it a little fatter than the rest of the fingers. And one more thing I want to do is rotate a little bit because most thumbs are kind of have a little bend to them. So I'm going to use my deselect mode. Roll that around there. So we get just to that axis right there. And then again, I'm going to go ahead and add just a bit of a curve to it with my rotation. There we go. Okay. And there's the thumb as it should be. Let's go ahead and roll that around a little bit more. In this axis. And a little more in that axis. Okay, now I'm going to use the same technique to stitch this together that we stitched these together, and then I'll go ahead and continue to extend this back out to create the rest of the hand. Now you can see once I've got those stitched, And with the sub patches turned on, you get a nice blending area in there. And if we look at the back side here, you can see that that's all stitched into one contiguous mesh as well. Now if I turn this onto wire shade mode, wireframe shade, you can see our polygons along the back here. These polygons over here look a little bit non-uniform. So what I'm going to do is I'm going to grab these two polygons, and there's a tool called Spin Quads. And Spin Quads under the polygon options, under transform. And Spin Quads basically looks at these two polygons and recreates them in different orientations. So if I say Spin Quads, you see it rotates it around. And I can look at it in different ways and see which way looks the best. There's the original. There's a new version. Another version. And you can see how it changes the contouring of the NURBS patch as well. At first glance, this one looks like it might match because this polygon looks good. But then you see this creates an interesting anomaly along the top. So we spin it one more time. We see now we have a nice consistent view across the back and a nice consistent view here. It's an important thing to do when you're looking at your model. Don't just look at the solid shaded view. Look at the way the polygons are aligned and make sure those polygons have a smooth flow. It's amazing how much this will actually affect the final render. You get a much better looking surface if your polygons are aligned. And even something just as simple as spinning these two quads has really dramatically impacted the overall curvature of the model. Another thing that's important about that is that as I add geometry or extrude this out, any kind of surface anomaly I have at the base is going to get amplified as I extend those polygons out in the back to create the back side of the hand. Okay, so what we want to do now is go ahead and extend this out to finish off the hand on the back side. So to do that, simply grab these polygons here, and we'll just use smooth shift, and I'm just going to activate it without doing any modification using my right mouse key. And we'll go ahead and zoom out a little bit here. And you can see I've got another set of geometry that I can work with, so I just start using my stretch tool and move tool and move to pull those back. Go ahead and stretch it in a little bit towards this side, so we start pulling it away from the thumb. You can see here we need that to pull away from the side of the thumb there. And we want the side of the hand here to continue to go straight. So just move that down a little bit. Smooth shift again. Keep pulling. And you just keep doing that until you get enough segments. Stretch that in a little bit. Start to create a wrist. And we'll go ahead and smooth shift it one more time. And we can start then pulling that back and then widen it out again. Sort of a creepy, spindly hand that we have going on here, but you get the general idea of the modeling techniques associated with building this hand. Now, an interesting thing, earlier when we built the first finger, I added the weight maps for the fingertip, the middle section, and the base. I also drew in some skelegons. Well, this is one of the cool things about building these things directly into the model, in that when I copied that single finger and duplicated it to make it the other fingers, also the skelegons were copied and the weight maps. Let's take a look at that. Here we can see if we change our viewport here to weight shaded view, you can see there's my back section, there's my midsection weights, and there's my fingertip weights. If we take a look and do a selection based on skelegons, we'll select all the skelegons, and there you can see are the skelegons that were created. And as I manipulated the points in each finger, I was also manipulating the points in the skelegons so they match perfectly with the new rotations and scale of each finger joint. Let's go ahead and go now over to the animation section. And here we have the object loaded up. First of all, we'll go over to settings and we'll run convert skelegons. That converts all those skelegons into bones that I can now select by clicking on them. Now what I want to do before I start manipulating the bones, if I go ahead and rotate one of these bones, let's just lock it off. Down here we can lock off heading, pitch, and bank. We'll set it just to pitch. If I rotate that, you can see pretty good, but it's affecting the entire model. Okay, this is where it comes into the using the weight maps. If I go to the palette for bones here, I can choose the weight map for that particular bone. Since this is a middle bone, I'll choose midsection. Then I can use my arrow key down, and we'll use the tip for that one. And I just go through here and quickly assign the appropriate weight maps for each bone. Middles for the mid ones, tip for the tips. Pretty quick and easy to run through there and get those set up. All right, that's it. So one other thing I want to do, generally with fingers, because fingers are so close to each other, and we're sharing weight maps between the different knuckles, we'll set a fall off range a little higher so that the effect of the bones doesn't spill out across the knuckle joints. So to do that, we go to our fall off type and we'll just set it up to 16 and see how that works. And we go ahead and rotate that, and you'll see it's just affecting the appropriate section. It's not affecting the bones around it. Again, we can rotate that down. Cool thing is we can multi-select bones here, so I can just go ahead and grab all these guys here like this. Spin that around, and we'll just disable everything but pitch. And we start to roll that down, and you can see I can just roll them all around at the same time. I've got my sub-patch setting pretty low for the object. So if we go over here and we go to P, we crank that up to like 3. That's going to smooth it out quite a bit. And of course, the other thing we want to do is turn on surface smoothing. So for the hand, we'll just hit smoothing. And now we've got the nice smoothing on there. So as we rotate these around, you're going to get the appropriate flexion, so on and so forth. Okay, well, we've covered a lot of ground, hit a lot of power modeling tools, some organic tools, VMAP creation and editing. We even hit into the skelegons, weight map creation. It's really a very deep application, and I think you'll find that as you start working with the tips and the tools that you've learned today, you'll find that by combining them in interesting ways, there's really nothing you can't accomplish. So until next time, keep on animating.